Hey, eighth graders, you are getting ready for your CBA on Monday. So hopefully you have completed all of your study guide and you're simply watching my video to check your answers. All right, so number one, the 1 through 4, they're all asking the same question. Do the following side lengths create a right triangle? So we're talking about right triangles, and we're using the Pythagorean theorem. A squared plus b squared equals c squared. So C, of course, has to be the longest side. So number one, we would plug in 3 and 4 for the side lengths, the legs. The biggest number must be letter C. Well, when we square 3 and we square 4 and we square 5, we see that we have a true statement. So number one is yes, it would make a right triangle. Oh, it's supposed to say yes. All right, what about the second one? We have 4 squared plus 9 squared equals 10 squared. 4 squared is 16 plus 81, and 100 would be 10 squared. Well, this is not true. 81 plus 16 is not 100. What would that be? 97? 97 is not equal to 100. So the answer for number 2 is no. Number 3, let's do 5 and 12 for the legs. The biggest side, the longest side must be C. 5 squared is 25. 12 squared is 144. And 13 squared is 169. And this is actually true. 169 does equal 169. So number 3 is yes. And then this one, we're going to have 8.2 squared plus 6.3 squared. Does that equal 10.2 squared? I don't know. When I put it in my calculator, I find that 8.2 squared plus 6.3 squared is equal to 106.93, and 10.2 squared is 104.04. So it's close, but no. Number 4 is no. So we have yes, no, yes, no. All right, the next question says, Juan is building a table for his garage. The sides of the table are 26 and 16. So let me, uh-oh, I didn't mean to do that. So let me draw a table. It says, ooh, that's messy. The side lengths of his table is a 26 by 16. The question is, in order for this to be rectangular, in other words, a rectangle has all right angles, correct? So we want to make sure the table has right angles. So basically, we have 2 right triangles. So in order for this table to be rectangular, we have to use the Pythagorean theorem. So we're going to do 16 squared plus 26 squared to figure out what the diagonal needs to be. So 16 squared is 256 plus 26 squared is 676. And that equals, when I add that together, we get 932. So that's C squared. So to find C, we would find the square root of both sides, and the square root of 932 is about 30.53 inches. Okay, or if it said round to the nearest tenths, it'd be 30.5. All right, the next one, number 6, says find the distance between the 2 points. So remember, we're going to make a right triangle. So either you can make your right triangle below it by making, you're supposed to make a horizontal and a vertical line, you guys. So that's my horizontal line. That was supposed to be my vertical line, which I can't draw. Or I could even make my horizontal and vertical lines above it. Why isn't that erasing? I don't know. Let's see. Erase. All right, so if I wanted to, I could make my vertical line here, which is very difficult for me to draw for some reason. All right, so anyway, the side lengths are 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to know the diagonal, which is the hypotenuse of a right triangle. So I'm going to do 3 squared plus 9 squared is equal to c squared. 3 squared is 9 plus 9 squared is 81. So 81 plus 9 would be 90 is what c squared equals. So now I'm going to find the square root of both sides. So the square root of 90 rounded to the nearest tenths would be 9.5. Or rounded to the nearest hundredths, it would be 9.49. All right? Whatever the directions tell you to do. Hope you guys are doing great. All right, number 7, a cake decorator rolls a piece of stiff cardboard paper to form a cone. He plans to use it by cutting the tip of the cone off and use it as a funnel to pour sprinkles from a large container into a smaller container. The cone has a radius of 5 centimeters and a height of 16 centimeters. What is the volume of the cone before he cuts the end off? So let's start with our formula for a cone. For volume, it would be 1/3 times pi times radius squared times height. All right, so it doesn't say, but let's go ahead and use 3.14 for pi. So I'm simply going to plug in what I have. So pi, let's use 3.14 for pi. And then our radius is 5, so we're going to square 5, and we're going to multiply it by our height of 16. So I'm going to plug that right in my calculator, 3.14 times 5 squared times 16. I'm going to divide all of that by 3. So my answer is 418.7 centimeters cubed. That was the volume before he cut the end of the container off. All right, next we have Eric is trying to go to Tim's house to play video games. Eric will walk 10 meters east. So if they both, let's see. So Eric will walk 10 miles east. Whoops. 10 miles east. I don't know why it's not writing. There we go. And then he's going to walk 7 meters south. And then it says to the nearest meter, how many meters would be saved if it were possible to walk through the lake? So right now, Tim walked 17 meters, right? That's how much he walked in total. We want to know how much he would save if he could go through the lake. So the lake, obviously, you can't walk through a lake, but that would be the hypotenuse of a right triangle. So we would do 10 squared plus 7 squared would equal our hypotenuse squared. So 10 squared is 100. 7 squared is 49. And so we're going to find the square root of both sides. So the square root, square root. So what is the square root of 149? The answer is 12.2 meters. So the question is, how much would he have saved? How many meters would he have saved? So if he walked 17 and he could have walked 12.2, then he saved 4.8 meters. He would have saved if he went through the lake. Okie dokie. All right, number 9, a television size is identified by the diagonal measurement of the screen. So Julia has a good size television. She has a 55-inch by 27-inch. So how would they advertise it? They always advertise it by the length of the diagonal. So we're going to do 27 squared plus 55 squared equals c squared. So 27 squared plus 55 squared, according to my calculator, is 3,754 is what c squared equals. So now we find the square root of both sides. And I say the answer is 61.3 inches in diameter. Question is, what is the length of the television? Oh, I did it wrong. Oh, they telling us 55 is the diagonal. Whoops, sorry, you guys. I almost messed that one up. Let me go back. I apologize. All right, so if it's already been identified as a 55 inch, that means the diagonal is 55 inches. Did you guys, y'all were about to email me and tell me I was wrong, weren't you? So we want to know how wide, what is the length? So this is 27. We don't want to know the length. I don't know, but we are going to use our Pythagorean theorem. So we know 55 is C squared, or C, not squared, but C. And then 27 can either be A or B. It doesn't matter. So 27 squared is 729. And 55 squared is 3025. So we're going to subtract 729 from both sides. Oop, I ran out of room. So 3025 minus 729 is equal to 2296. And then to find the length, we're going to find the square root of both sides. And I am showing 47.9 or 47.92. All right, I hope you guys are getting these right. I bet you are. All right, let's move on. Number 10, we're finding our hypotenuse of our triangle, right here. So we're given one side length, and the other side length is the square root of 64, because this is supposed to be a square. I know it looks like a rectangle, but if this is a square with an area of 64, each side length of the square has to be 8. 8 and 8 to make an area of 64. So we're going to use 8 squared, which is 64, obviously, that's what it says, equals our hypotenuse squared. So we have 64 plus, what is 15 squared? 225 equals C squared. 225 plus 64 is 289. I think that's a perfect square, isn't it? And the square root of 289 is 17. Yep, it's a perfect square. So our hypotenuse is 17. All right, number 11, a ball is in a cylinder can. The tennis ball has a radius of 4, so our radius is 4. The cylinder has a height of 11. How much wasted space or air is in the container? So the ball touches the top and bottom and both sides of the cylinder. All right, so that means our cylinder and our ball has the same diameter, which wouldn't make sense if the radius is 4. This is a bad question. Anyway, if this touches each side, this should be 8. The height of the can should be 8. Okay, so this is not a good question, you guys. I'm going to change this to 8. So we'll just use the numbers that they gave us, all right? We'll use the numbers they gave us. All right, so let's do the cylinder volume is pi times radius squared times height. And then our sphere, our sphere's volume is 4/3 times pi times radius cubed. Yeah, this is not a good question. I'm going to have to change that. All right, anyway, I'll do it next year. So our volume for our cylinder is 3.14 times our radius squared. Our radius is 4, so 4 squared is 16. And the height of the can is 11. So if we put it in our calculator, I got 552.64. And then our sphere is 4/3. times 3.14 times 4 cubed. So that one, I got 267.95. And then how much area, or what's the volume of the air that's left, the section that's not filled up with the basketball? We're going to subtract those two numbers. So 552.64 minus 267.95, and I got 284.69 cubic inches. All right, how you guys doing? All right, number 12. How much grain does a silo with a diameter of 8 feet and a height of 35 feet hold? Assume the top of the cylinder is a hemisphere. So this time we're gonna add them together. So for our cylinder, we're gonna do pi times radius squared times height. And for our hemisphere, we're gonna do, a hemisphere is half a sphere. So instead of 4/3, we're gonna put 2/3 times pi times radius cubed. So once we get both of these, this time we're gonna add them together. So we're gonna do 3.14 times the diameter of 8, so that's a radius of 4 squared, times the height of 35. And then over here, we're going to do 2/3 times 3.14 times 4 cubed. All right, we're going to put these in our calculator. Squared times 35. So 1,758.4. 2/3 times 3.14 times 4 to the third is 133.97. So we're going to add these two things together. 133.97 plus 1,758.4. I got a combined volume of 1,892.37 cubic feet. All right, if y'all disagree with me, please send me a message and let me know what you think. All right, number 13. To help support a flagpole, a 60-foot long rope is tied to the pole at the point 50 feet above the ground. The rope is pulled tightly and anchored to the ground. How far away from the base of the pole is the rope anchored? You must be able to draw and label a diagram of this scenario. All right, so we have a flagpole. Whoops. Where'd my pen go? Oh my goodness. Hold on. We got a flagpole, right? And it is covering up my words up here. So the flagpole, so we're tying a rope at 50 feet from the ground, okay? And then the rope is 60 feet long, so they're pulling it over here and they're anchoring it. The question is, how far from the end of the rope to the bottom of the flagpole? So that's the part we're looking for. So we're going to use our Pythagorean theorem. So 50 and x is our legs, and 60 is our hypotenuse. So we're going to do 50 cubed, or excuse me, squared is 2,500, and 60 squared is 3,600. So now we're subtracting 2,500 from both sides. We have 1,100. And now we need to find the square root of both sides. And I got 33.17 feet. That's how long it is from the bottom of the rope to the bottom of the pole. All right, we're almost done, you guys. Angel is attempting to find the missing side length of a right triangle given leg A is 13 and the hypotenuse is 21. What is Angel's error? So the hypotenuse is 21. So the hypotenuse must always be what letter? Letter C. Right. So the mistake, what is Angel's mistake? Angel's mistake is he should have used 21 as letter C. And how should he correct it? To correct it, we would rewrite this. Make sure we use 21 for C. All right, so that was Angel's mistake. All right, Carpenter has boards that are, let me get rid of this writing, you guys. Nope. 6, 8, 6, 8, 9, and 10. So we want to know, out of these 4 boards, is there any way to use 3 of them and create a right triangle? Well, let's just try it. Let's see if 6 squared plus 8 squared equals 9 squared. Well, 6 squared is 36. Hi. Good, thank you. Whoops, that'd be 64. Sorry. So this would be 64 equals 81. Nope, that's not right. So we could not make a triangle with boards that were 6, 8, and 9. However, I do notice that 36 plus 64 does equal 100. And I also know that 10 squared is 100. So we could make a right triangle if we use the boards that are 6, 8, and 10. 6, 8, and 10. All right. Erase this. All right, number 16, the area of square A is 3,600. So the area of this square is 3,600. The area of square C is 10,000. Oops. The question is, what is the side length of B? Okay, so obviously A squared is 3,600. That is the area of A. And we know that the area of C, so C squared is 10,000. Because it's already squared, it's the area. So we're going to subtract 3,600 from both sides. So B squared would equal 6,400. And when we find the square root of both sides, the square root of 6,400 is 80. So B, the length of B, is 80. If it asks what is the area for this square B, the area would be 6,400. All right, you guys, one more, I think. A spider is taking up residence in a small cardboard box measured by 8. It measures 8 inches by 5 by 4. We want to know the diameter. All right, so hopefully y'all remember how to do 3-dimensional. So this time, since we have 3 dimensions, we're going to square each of the 3 dimensions and then find the square root of the answer, the diagonal. So 4 squared is 16, 5 squared is 25, 8 squared is 64. So when I add all that together, 16 plus 25 plus 64, I get 105. And then I'm going to find the square root of that number. So the diagonal is equal to 10.25 or 10.2. All right, you guys. So your test is Monday, so make sure you are prepared for it, and I will see you guys then. Have a great day.